Hi students, welcome you all for today's video. Today we'll continue about the application of a trigonometry in practical or where the trigonometry is actually utilized. So in the previous video we have discussed question number 1 and 2 and today we'll start with a question number 3 of exercise 9.1. So a question tells a contractor plans to install two slides for a children to play in a park. For the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter. You can see here for younger children lesser than 5 years, the height required is 1.5 meter is inclined at an angle of 30 degrees. So it is inclined at an angle of 30 degree to the ground. Whereas for the elder children, she wants to have a steep slide at a height of 3 meters. So height is 3 meter for the elder children and inclined at the angle of 60 degree. So angle is 60 degree to the ground. What should be the length of the slide in each case? Means we have to find out AC and PR respectively for the younger children and the elder children, so that will be your length of the slide. So we have the angle and we have the opposite side and we need the hypotenuse. So which trigonometric function it will suit? It will suit the sine theta, right? So theta is here 30 degree. So sine theta is given by opposite by hypotenuse. So opposite is 1.5 here and hypotenuse is AC. So required quantity is AC. Let's bring to the left hand side. So it will become 1.5 by sine 30. So that is nothing but 1.5 by what is sine 30? We know it is 1 by 2, right? So this will go to the numerator and become 1.5 into 2. So that is 3 meter. So length of the slide required for the younger children is 3 meter. So let's calculate for the elder children. Similarly, we'll apply the sine function here. So sine 60 is given by height 3 meter divided by the hypotenuse, that is required dimension. So PR is equal to 3 by sine 60. So what is sine 60? Sine 60 is root 3 by 2. So it will become 3 into 2 divided by root 3, right? So root 3 will get cancelled. It will become 2 root 3 meter. So this is the length of the slide required for the elder children. So next question is question number 4. There it says that angle of elevation of the top of the tower from the point on the ground which is 30 meter away from the foot of the tower is 30 degree. Find the height of the tower. So let the height of the tower is this. So what is the distance? It is 30 meter away from the foot. So the angle that is given is 30 degree. Let be A, B, C. So what we have to find out? We need to find out the height of the tower. So that is AB. So we have the angle, we have the adjacent side and we need the opposite side. Which trigonometric function it will suit? So that will suit the tan 30 is equal to, what is tan? That is opposite by adjacent. Opposite is AB, the unknown part here, and the adjacent is 30, right? So AB is equal to, will get 30 into tan 30. So it is tan 30. The tan 30 is nothing but 1 by root 3, right? So this we can write 3 into 10, 1 by root 3. So root 3 ones are and root 3 is a. So it is 10 root 3 meter. So this is because the 3 is the product of root 3 into root 3. So that we have utilized here. So what is the height of the tower? It is 10 root 3 meter. So next we'll move on to the next question, that is question number 5. A kite is flying at a height of 60 meters above the ground. So it is flying at a distance of 60 meters. The string attached to the kite is temporarily tied to a point on the ground. So The string is tied at this point. Let name it as ABC. So AB is the height at which the kite is flying currently, and AC is the string, and it is tied at the point C at the ground. The inclination of the string with the ground is 60 degree. Find the length of the string, means we have to find out AC. So angle is known here, opposite side is known, and we need the hypotenuse. So which function we have to use? We have to use sine function. So sine 60 is given by opposite, that is 60, divided by hypotenuse, that is the length of the string here. So AC will become 60 divided by sine 60. So what is sine 60? Sine 60 is root 3 by 2. So this will turn into 60 into 2 by root 3, right? So that is nothing but 120, or we can write 60 into like 3 into 20 into 2 by root 3. So this is expansion of 60. So root 3 into root 3 times of the 3. So answer will become 20 into 2 is 40. The 40 root 3 meter is the length of the string. So next we'll move to the next question. Question number 6. It says a boy with a height of 1.5 meter is standing at some distance from a 30-meter tall building. If PS is the building height, so that is given 30 meter, and ST is the height of the boy, so that is 1.5 meter. So what they are telling, angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walks towards the building. So find the distance he walked towards the building. So we have to find out in this figure the SR we need to find out. So PS is given 30 meter, but angle of elevation is given with reference to this line. So we have to find out the distance or the height of the building with respect to point Q, right? So we have, what is the PQ will get? So PQ will get it as total height. So that is PS minus the height of the person. So then let it be QS here. So we know QS equal to ST. So that is 30 minus 1.5. So that will get it as 28.5. So here one thing I will do is I will express this in the fraction form. So we'll get the fraction as 57 by 2 meter. Just we are converting it to fraction form so that it will ease the calculation in the further step. So what we have to find out? We have to find out the SR. So for that we know the PQ is common for both the angles. So that is the opposite side, and we need to find out the adjacent side. Which function it is? It is tan function. So in triangle PSQ, tan 30 is given by opposite by adjacent, right? So opposite is here 57 by 2, and adjacent we know that, don't know that, we need to calculate, that is SQ. So SQ will be 57 by 2 into tan 30. Tan 30 is 1 by root 3. So it will go to the numerator and it will become 57 by 2 root 3. So we will write here root 3 meter. So why I am calculating SQ is SQ minus RQ will get you the SR. So similarly consider triangle PQR. So in PQR we'll get tan 60 is equal to, opposite is same, 57 by 2, adjacent is RQ, that we need to find out. So RQ is equal to 57 by 2, tan 60 is root 3. So that will be 57 by 2 root 3. You can see here root 3 is in the numerator whereas root 3 in the denominator. We need common terms to subtract or addition, it makes easier. So I observe that 57 is the multiple of a 3. So which we can write it as 19 into 3 by to root 3. So can we cancel root 3 times the root 3? So it will become 19 into root 3 by 2, or it is 19 root 3 by 2. So we have got SQ and we have got RQ. We need to find out SR, right? So SR, the distance is given by the total distance, that's the initial distance of the boy from the foot of the building minus the distance he was at the end of his travel. So SQ is, what is SQ we got? We got it as 57 root 3 by 2 minus, we got RQ as 19 root 3 by 2. So can I take root 3 by 2 outside? So it is root 3 by 2. If I take outside, it will become 57 minus 19. So that is nothing but 38. So 38 root 3 by 2. So here 2 ones are 2 19s. So final answer is 19 root 3 is the distance he walked towards the building. Let's look at the answer once again. If you have any doubt or anything, you just do a comment so that I will reply to you. So we quickly move to the next question, that is question number 7. So it is saying from a point on the ground, the angles of elevation of the bottom and the top of the transmission tower fixed at the top of a 20-meter high building are 45-degree and 60-degree respectively. So the building is this. So what is the building height they have given? Building height, it is given as 20 meter and the transmission tower is fixed above that. So from a point on the ground means this is at the level of this. So they are telling the top and bottom of the transmission tower. So at the bottom and top they are telling angle of 45-degree and 60-degree. So bottom is 45-degree and the top is 60-degree. Let's name the transmission tower as AB, C, D. So what we have to find out? Find the height of the tower. So we need to find out AB here with respect to our notations. So this is 45 degrees given. So in triangle DBC. So building, we have to take the center line. So it will become DBC. In DBC we have the angle and we have the opposite side and we need the adjacent side. So we have to take the tan function. So tan 45 is given by BC by DC, right? So what is BC? BC is 20. So DC we have to find out. So DC is equal to 20 by tan 45. So what is tan 45? It is 1. So 20 by 1 is equal to 20. What is DC? We got it as 20 meter. So next consider triangle full, that is ADC. So what is the angle for that? That is 60-degree. So tan 60 is equal to full length from the ground, that is AC. AC divided by DC, right? So what's the DC? We got it as AC 20. We'll substitute that. So we'll get the total height or the tip of the building tower, transmission tower from the ground is AC. So AC is 20 tan 60. So it is tan 60. Tan 60 is root 3. So it is 20 root 3. And we know that AC is the addition of AB plus BC, right? So we have got AC as 20 root 3 and AB is, we need to find out, and BC is 20, that is given the height of the building. So it will become, so AB is equal to 20 root 3 minus 20. So can we take 20 common here? So 20 into root 3 minus 1 meter is the height of your transmission tower. So one thing we have to be very careful in the question, the angle with respect to whether the bottom and top we have to take accurately, and it is installed 20-meter high building is installed on the 20-meter high building. So we have to draw diagram first. So if we are drawing the diagram, we'll come to know which trigonometric function we have to utilize, then it will simplify your work. We quickly move to the next question, that is question number 8. So it says a statue 1.6-meter tall stands on the top of the pedestal. So it is similarly like our previous question. So there is a pedestal. Let's name it as AB. So a statue is standing above that. So what is the height of the statue? That is 1.6 meter. Let BC be the height of the statue from a point on the ground. So ground is at the point A. So let's draw the ground. So angle of elevation of the top of the statue. So top of the statue is 60-degree, and from the same point the angle of elevation of the top of the pedestal. So what is a pedestal top? Is nothing but the bottom of the statue, right? So that is point B. So what is the angle is given here? That is 45-degree. Let's draw that. So this is 45-degree and this is 60-degree. So what we have to find out? Find out the height of the pedestal. So that we have to find out. AB is question mark here. So which function we have to use? Again, it utilizes the tan function. So tan 45 is given. So in triangle ABD, tan 45 is equal to AB by AD, right? But tan 45 is 1. So what indicates AB is equal to AD. So let's be the equation 1, because we don't know the AD and we have to find out the AB. So if we find out the AD, so that will be equal to AB from our equation 1. So next consider the next triangle, that is ACD. So that is tan 60. So tan 60 is AC by AD, right? So we don't know AD, but can we write AC? AC as AB plus BC. So we'll write denominator as it is, the AD. So AB is don't know, but BC we know it as 1.6. We'll substitute that and we'll write AD here. So can I replace AD with the AB here? So that will become AB plus 1.6 by AB. So what is tan 60? Tan 60 is root 3. So I will move that to the other side. So AB plus 1.6 into root 3 times the AB, right? So AB is here. So can I move this AB to this side or this AB to this side? We know that root 3 value is 1.73. So that is a bigger value. Let's move the left side AB to the right hand side. So it will become AB. If you are taking common, it is root 3 minus 1 is equal to 1.6. So which implies AB is equal to 1.6 divided by root 3 minus 1. So what we have to do next? If we get in the denominator root 3 minus 1, we have to rationalize. So to rationalize, what we have to do? We have to multiply by changing the middle sign. So root 3 minus 1, if we are changing, it will be root 3 plus 1. We have to multiply and divide that. So in the numerator, it will become 1.6 into root 3 plus 1. Denominator is in the form of a minus b into a plus b. We know that is a square minus b square. So a square is root 3 square. So that is 3 minus 1 square is 1. So that will become 1.6 into root 3 plus 1 divided by 2, right? So 2 ones are and 2 0.8. So what is the height of the pedestal is 0.8 times the root 3 plus 1. So what is the unit here? Meter. So that is the height of the pedestal.